Okay. So what we spoke about last week Friday, about last week Friday as well. I uploaded the videos for Thursday, and then for some reason on Friday when I recorded the video, it didn't record the screen. So you've got audio, and then you just have like this blank screen here. It's just me talking with a screen. So I don't know why I did that. So yeah, I have not uploaded the videos for Friday, and I'm not going to do that because you can't see anything, right? So I do apologize, but at least on Friday, we didn't miss much. We just missed the end part of chapter 27. I do apologize. Anyway, today we are doing what in a previous version of this textbook was essentially the appendix to chapter 27. It's the ISLM model, so you've been given the scanned handout from this portion of the chapter. I did mention to you as well that, again, in some other version of this textbook, it wasn't chapter 27, it was chapter 29, and there were slides for the ISLM model from chapter 29, appendix, from that previous version of the textbook. So what I've got here are those slides, and we will work from these slides as the basis, and then I'll upload them onto Sakai so that they are there for you as well. Okay? What I haven't thought about, but what I will do is I'll upload the ones that don't have any scribbles on from me as well. Okay? So I upload the ones that are just blank, and then I'll upload it after it's been written on by me in the lectures, so that you can have both copies. Whichever one works better for you, you can then use. So we did end on Friday just kind of overviewing this little portion of the chapter. We said that there's not a lot that happens here in terms of volume, but there's quite a lot that happens conceptually. So we begin with the IS curve, which is essentially an equilibrium. It's a point of equilibrium in our aggregate expenditure model. We're going to join a whole bunch of equilibrium points in the aggregate expenditure model. Then we move on to the money market, and we join a whole bunch of points of equilibrium from the money market. And when we do that, we end up with the LM curve. Okay? So the IS curve, it's going to join a whole bunch of points of equilibrium. So here we've got point A, point B, point C. All of those are points of equilibrium. Point A, point B, point C to get our IS curve. In the money market, we have points D, E, F, points of equilibrium in the money market. Points D, E, F, the LM curve. And then we're going to bring our IS and LM curves together. And ultimately, we're going to show that if you shift the LM curve, so if we shift the LM curve and we have different points of equilibrium in our ISLM model, you end up with an aggregate demand curve. So we can derive our aggregate demand curve from the ISLM model. We're also going to use this ISLM model to analyze fiscal and monetary policy actions. So here we have two different examples. Here we have a shift in the IS curve through fiscal policy, and showing the effects when we have an upward sloping LM, showing the effects when we have a horizontal LM. Here we've got shifts of the LM curve, which represent monetary policy. We have a downward sloping IS, we see the results. We have a vertical LM, and we shift the IS, we see the results are slightly different. So that's the overview of the chapter in total, and the slides essentially follow exactly what is in that handout. So we'll quickly go over our objectives for this chapter. We're going to briefly talk about how we arrive at this ISLM model, where it comes from. We're going to derive the IS curve. We're going to derive the LM curve. We're going to put IS and LM together. We're going to derive the IS-LM equilibrium. Then we're going to use that ISLM model to analyze relative effectiveness of fiscal policy and monetary policy. And we're going to use the ISLM model to derive the aggregate demand curve. Okay. Any questions at this stage? No? Okay. So why do we have this ISLM model? What makes it useful? Well, it provides a tool for analyzing fiscal policy and monetary policy, and it allows us to derive the aggregate demand curve. So the two things that we're going to do right at the end of the chapter, they are really the purpose of the ISLM curve. What does the ISLM model actually show us? Sorry, I said curve, but I meant model. The ISLM model shows us how real GDP and interest rates are determined simultaneously by equilibrium conditions in the aggregate expenditure in the aggregate expenditure model and the money market model. It was invented by some guy called John Hicks back in the 1930s, 40s, and it's basically everything that we did with that Keynesian aggregate expenditure curve, the Keynesian model, right? It just takes that model and kind of formalizes it by adding it to the money markets to say, right, let's join our two models together, our money market and our aggregate expenditure curve, and let's see how it all looks. So once again, the IS curve shows combinations of real GDP and interest rates, okay? Combinations of real GDP and interest rates at which the aggregate planned expenditure equals the real GDP, okay? So all points where aggregate planned expenditure equal real GDP for different interest rates. Then there's a couple of slides here which I'm going to skip and then come back to, where we've got some tables, but I'd rather just begin with the diagram from our aggregate expenditure model, which you are familiar with. So let's work through what we are looking at here. In part A, so here we're looking at part A, the aggregate expenditure model. This is part A. In part A, the aggregate expenditure curve, AEA, so here's our aggregate expenditure curve, says corresponds to the first row of this previous table. We'll come back to the table. The important part here is that the interest rate for aggregate expenditure A is assumed to be 6%. Let me make this a little bit bigger, actually. So we assume for aggregate expenditure A that the interest rate is 6%. Okay. So let me now ask you, if the interest rate decreases, okay? If the interest rate decreases, what happens to investment spending? What can we expect should happen to investment spending if the interest rate decreases? We expect investment spending to go up. Okay. If investment spending goes up, what happens to our aggregate expenditure curve? It increases. In other words, it shifts upwards. Okay. So if my aggregate expenditure curve AEA is at 6%, with a fall in the interest rate, are you happy I would have a new aggregate expenditure curve, call it AEB, that would be above AEA? Everyone with me? So if I just sketch it in, I could sketch in another curve here, and I'd call it AEB, and AEB would correspond to, say, an interest rate of 5%. You with me? Okay? When my interest rate was 6%, I had an equilibrium level of real aggregate expenditure, an equilibrium level of real GDP, which was given by point A. You happy with that? When my interest rate decreases, what happens to my equilibrium level of GDP? You happy that it increases? Okay? So if I summarize what I've just explained to you, or what you've just explained to me as well, if the interest rate goes down, the equilibrium level of GDP in our aggregate expenditure model goes up. With me? Excellent. So at our initial interest rate, 6%, okay, 6%, I had an equilibrium level of GDP, 1,100. If I now plot interest rates against real GDP, I can plot this point here, point A. You with me? That was my initial equilibrium point. What happened when I lowered the interest rate? When I lowered the interest rate, what happened to equilibrium GDP? It increased. So if I now, so this was our initial, let me make it even bigger. Here was our initial 6%. We lowered the interest rate to 5%. We had a new equilibrium point, point B, corresponding to a higher level of GDP. I can now plot point B. Initially point A, now point B. Okay, what's going to happen when I lower my interest rate yet again? I lower my interest rate again, and my equilibrium level of GDP increases. Why? Because my aggregate expenditure curve shifts up once again, right? So I can draw aggregate expenditure curve C. Are you happy that I now have 3 different points, A, B, and C, and I can join all of these things together? If I join all those points, what am I plotting? What is the relationship that I am currently sketching out? I'm sketching out a relationship between interest rate and GDP. And I'm looking at all the points of equilibrium in my aggregate expenditure model when I have different interest rates. I change the interest rate, I get a different equilibrium level of GDP. And the lower the interest rate, the higher the equilibrium level of GDP. So that is called the IS curve. Okay, it's called the IS curve because it's a summary of all the points where investment equals savings. So where I, investment, equals savings, IS curve. How do I know it gives me all the points where investment equals savings? Because each of those points is a point of equilibrium in my aggregate expenditure model. What do I know about all the points of equilibrium in my aggregate expenditure model? Well, let's compare it to a point that's not equilibrium. So let's say I was on this curve, AEC, at this point. So my level of GDP is 1,100, but my level of expenditure is greater than 1,100. Let's work through the process here. What's happening? We are selling more goods than we are producing. That's a signal to firms. What happens? Their inventories are getting drawn down. Okay, their inventories are going down, lower than what they expected them to go. It's a signal to firms. What should they do? They should start increasing production. As they start increasing production, GDP starts increasing. But remember, of course, with an increase in GDP, we also have an increase in aggregate expenditure. That increase in aggregate expenditure moves us to new points along aggregate expenditure curve C, AEC. As we move to new points along AEC, we find that firms still are selling more than they anticipated, and so they still continue to produce even more, until eventually we end up at a point C. At point C, firms are selling as much as they are producing, in other words, what they intended, right? Aggregate planned expenditure equals actual output and actual expenditure, okay? What we know, therefore, at point C is any planned investment is equal to savings, right? At any point of disequilibrium, okay, people are spending, like if we took our initial point, people are spending more than they are earning. If they are spending more than they are earning, they must be drawing down on their savings, right? Okay. At point C, they are spending as much as they are earning. They are not drawing down on their savings. They are saving, right? They are contributing towards savings, and those savings are being used for investment, and that investment is exactly what firms plan to invest. There's no unplanned changes in inventory, so everything they wanted to invest, they are investing, and that investment is equal to whatever it is that households are saving. You with me? Okay. So at point A, point B, point C, all the points of equilibrium in the aggregate expenditure curve are all points in which our planned investment is equal to our savings. So I say investment, really I should put there planned investment is equal to savings. Is everyone happy with this IS relationship? Complicated or manageable? Manageable? Anything that you're not happy with? Anything I need to recap here? No? Okay. Then let me go back to those tables that we saw previously and which are in your textbook. What the table is showing us is that at points A, B, and C in our aggregate expenditure curves, so these points A, B, and C, if we look at each one of those points, the interest rate is at point A 6%, point B 5%, point C 4%. And if we look at different levels of real GDP, when our real GDP level is 1,100, in other words, if we look at this level here, 1,100, okay, at an interest rate of 6%, okay, 1,100 real GDP, an interest rate of 6%, so that's AEA. An interest rate of 6% with 1,100, what is our aggregate expenditure? It's 1,100, right? At 5% with real GDP of 1,100, what is our aggregate expenditure? It's some level over here, and they call it 1,150. At an interest rate of 4% with GDP of 1,100, you've got some level up here. What is that? 1,250 thereabouts. 1,200 is what they call it. Okay? So if we keep this level of GDP constant and we look at those different interest rates, we get different levels of aggregate planned expenditure. And there's only one of those levels of aggregate planned expenditure that is equal to the level of real GDP, and that is the level of aggregate planned expenditure that corresponds to an interest rate of 4%. Same thing happens if we look instead at a real GDP value of 1,300. Okay, so 1,300 at 4%, sorry, at 6%, okay, at 6%, that's AEA. At 6% with 1,300 as our level of GDP, we have some level of outputs. Some level, call it 1,000, I don't know, 1,175 or something. What do they call it? They call it 1,250, sorry. So my estimate was out. Okay, then at 5%, if we look at real GDP of 1,300 with a 5% interest rate, so 5% interest rate corresponds to aggregate expenditure curve B. With 1,300, what's our level of spending? It's 1,300. Okay, so here's our second 1,300. And then again at the lower interest rates, with real GDP of 1,300, we end up with spending of 1,350. Which of those points is an equilibrium point? It's interest rate 5%, okay, and then interest rate 4% point C, okay? So that's how they put that table together. You got it? Okay? That's the IS side of things. what I want you to do quickly is get out a piece of paper and a pen. You're going to draw some stuff. Actually, we're going to do quite a lot of drawing today to help cement these ideas. The first bit of drawing is going to be very simple. We're just going to basically redo what we've done here. The second bit of drawing is also going to be simple. We're going to redo the LM curve like we're going to see it. The third bit of drawing is also going to be simple. We're going to combine the IS and LM curves. You're going to be thinking, why am I wasting my time? And then I'm going to say, cool, now take this point of disequilibrium and explain to me how we get to equilibrium. And suddenly you're going to realize, hang on, I haven't been paying attention. Okay. So, I know this seems simple, and yes, it is simple. I agree with you. But seeing it done for you and trying to do it yourself, man, those are two different things. Okay? So first of all, you're going to do what you've already seen done. I would like you to plot an IS curve. Okay? But I want you to plot it in stages, like we have done here. So plot an initial aggregate expenditure diagram. So let me start you off exactly as I anticipate things going. So you're going to plot your initial aggregate expenditure curve. If we're plotting aggregate expenditure, we've got output against aggregate expenditure. We have a 45-degree line. And you have an aggregate expenditure function, AE, and we're going to call it whatever you want, but I'm going to call it AE1. And we have some level of output. And we're going to call this Y1, which corresponds to aggregate expenditure level AE1. And AE1 here corresponds to some level of investment, call it investment 1, which is a function of interest rate level R1. Okay? So if we've got a point of equilibrium, which is showing us a relationship between Y output, Y1, and interest rates R, and we've got here R1, then I can choose some level of interest rate, R1, and it's going to correspond to some level of output, Y1. So here's my Y1, here's my R1, and where these two intersect, I can draw my first point, my first relationship point. So what then happens if I decrease the interest rate? So the interest rate, R1, is going to decrease. When it decreases, it's going to decrease to R2. When my interest rate decreases, what happens to my level of aggregate expenditure? It does. Well, remember, R1 was associated with some level of investment spending, I1. With a decrease in R1, I'm going to shift to a different level of investment spending, I2, and I2 is going to be greater than I1. If I2 is greater than I1, my aggregate expenditure curve shifts up. Now, if I've got some level of output Y1, if I've got output level Y1, but I've got expenditure level, let's call it AE 1.5. What is the problem with aggregate expenditure level 1.5 compared to output level Y1? It's not equilibrium, absolutely. Why? Why is it not equilibrium? What is the problem with this point? Sorry? Yeah, you're saying? No? Okay. Absolutely. You're spending more than you're producing, so what should firms do? Start producing more. as they produce more and more and more, we eventually end up at a new equilibrium point. You with me? Okay, so now you can take over. I'll give you 2 minutes, just quickly finish that off and get your IS curve happy in your mind. To complete the plotting of our IS curve, are you happy that when we decreased interest rates from R1 to R2, I can choose some interest rate R2, which is, I can choose some interest rate R2, which is below R1. And R2, if I look at all the different values of y in relation to R2, at what point do we have equilibrium in our aggregate expenditure curve? Well, we've got some point corresponding, some level of output corresponding to Y2. Let's say some level of aggregate expenditure 2. So our output level here, Y2, and we can plot this down, right? Y2 is the level of output at which we have equilibrium in our aggregate expenditure model when our interest rate is R2. So now we can plot our second point. And now we have a relationship between interest rate and output that is downward sloping. It's an inverse relationship, and it is called the IS relationship. IS curve. Okay. May I continue? LM. What is the LM curve? Well, once again, we've got a relationship between interest rates and output. Except now when we're talking about the relationship, we're looking at the relationship in the money markets. In other words, we want to know what is the relationship between the quantity of real money demanded and the quantity of real money supplied. Remember that when we change the level of output, we change the transactions demand for money. Remember, when we increase output, we want to hold more real money balances in order to buy that output, right? Okay. When we shift our money demand curve, in other words, if GDP goes up, then we want to hold more money balances. Our money demand curve shifts which way? To the right. The money demand curve shifts to the right. Yes? When the money demand curve shifts to the right, what happens to the equilibrium interest rate in the money market? It increases. Right. So there's a relationship in the money market between the level of GDP and the interest rate. What do we think that relationship is going to be? If I increase output, what happens to interest rates? They increase. So if I'm going to plot interest rates against output, what's the relationship going to be? Upward sloping. It's going to be a positive relationship. That's exactly what we're going to draw, okay? So if there's some tables, we'll come back to the tables. Here's our diagrams. So we've got some level of money demand. Now this level of money demand is associated with some level of output, 1,100. So I'm just going to write that in there. This is the level of money demand when output equals 1,100. Well, let's do this. When y equals 1,100. Okay? Now if you remember from the diagram that I showed you in Chapter 25 from a slightly different textbook, here's our transactions demand for money, here's our asset demand. We add them together and we get the full demand, the money demand curve, right? This is our transactions demand. So when output increases, where's my common thing? Okay. When output increases, my transactions demand shifts to the right. When my transactions demand shifts to the right, what does my money demand curve do? Shifts to the right. Okay? Remember this? Okay. So if I now think of, I was initially at 1,100. I'm now going to increase my level of GDP to 1,300. When I increase my level of GDP to 1,300, what happens to my transactions demand for money? Increases. What's it going to do to my money demand curve? Shifts it to the right. So if I plot in the second money demand curve, I'm going to call it MDE. MDE is going to correspond to Y equal to 1,300. Okay? My point of equilibrium initially was at an interest rate of 4% in my money market. With an increase in output, an increase in money demand, what happens to my equilibrium? It increases. My line looks rubbish, but you get where I'm going, right? Okay, so my equilibrium interest rate now is 5. So now if I'm plotting 5 against 1,300, I can do a second point. Point E. You got it? So what do we do in this series of diagrams? Exactly that. We increase our level of GDP, we shift money demand, we get a new equilibrium point corresponding to a higher interest rate. Okay, then once again, if we increase output again, shift our money demand curve, new point of equilibrium, higher interest rate. Now, this is called the LM curve. It's called the LM curve because it's all the points from our money market where liquidity is the demand for money. In other words, demand for liquidity is your money demand curve. It's you're holding money. That's what you want to do. Remember, money is the most liquid of all the assets. Remember this discussion? What does liquidity mean? How quickly can you convert it into something else? And money you can convert basically as quickly as you want to. As soon as you want to spend it, you spend it. Right? So cash money is the most liquid of all the assets. So money demand is your demand for liquidity. So L, it's liquidity equal to money supply, MS. So money supply. So where money demand, liquidity equals money supply. Where L equals M, LM curve. Okay? If we now go back to those tables, what are they trying to show us? Same thing. If we look at different interest rates, so we've got here different interest rates as well as different levels of GDP. If we take our initial level of GDP, point D in these diagrams, okay, so point D, so our initial level of GDP at point D, which is 1,100. If we take our initial, if we take our initial level of GDP, 1,100, okay, at a level of GDP 1,100, given different interest rates, we're going to have different quantities of money demanded. Okay? In other words, look at our initial level of GDP, 1,100. That corresponds to our money demand curve, MDD. At an interest rate of 4%, we have a quantity of money demanded of 1,400. At an interest rate of 5%, we have a quantity of money demanded, I don't know what they tell us, but let's take a look, 1,350. You happy with that? In other words, the amount of money that we want is now lower. When the interest rate is 6%, then the amount of money we would want would be even lower. And the amount that they tell us it's going to be is 1,300. Okay? So for different interest rates, given our level of GDP 1,100, we have different quantities of money demanded. Now, if the quantity of money supplied is 1,400, what we want is the interest rate where the quantity of money demanded is equal to the amount supplied. Where is the amount demanded equal to the amount supplied? Well, it's at interest rate 4, right? So here's what we're looking for, 1,400 equal to money supply, and that is at an interest rate of 4%. When we have a higher level of GDP, 1,300, we can go through the same procedure. At 1,300, at an interest rate of 4%, what's our quantity of money demanded? I don't know, call it 1,450. Does that make sense? It's about 1,450. You with me? Okay, and they say it is, okay, 1,460. It's good enough, right? At an interest rate of 5%, what is our quantity of money demanded? When our money demand curve, when we've got 1,300 as our real level of real GDP, our money demand curve is MDE. And at an interest rate of 5%, the quantity of money demanded will be 1,400. And at 6%, the quantity of money demanded will be less than 1,400. So we can plot those 2 points in our table again. So we had 1,460, then 1,400, then some amount 1,340, which is below. So where, again, when we have real GDP 1,300, where does our money demand, quantity of money demanded, equal the amount supplied? Well, it's at this point here, which is which interest rate? 5%, right? So we're plotting the LM curve slightly differently. When we plotted the IS curve, remember we said at some interest rates we have some level of output. Where does the level of output then equal GDP? Okay? I mean not output, sorry. Where does the level of expenditure equal GDP? So we changed the interest rate, which changed aggregate expenditure, and we wanted to know where is aggregate expenditure equal to GDP. That was the IS curve. The LM curve, we've done it the other way around. We've said, right, take some level of GDP, given a level of GDP, where does the interest rate in the money market associated with that level of GDP lead to equilibrium in the money market? You get it? So in the IS curve, we started with different interest rates, and then we got different levels of output. In the money market, we were starting with different levels of output and then getting interest rates. Yeah? Okay. So now that you know how the LM curve works, here we go, LM curve. Let's plot it quickly. Except I don't need to now, I think I don't need to show you how to plot it. I want you to plot it using 2 points. Think about how you move from your initial point of equilibrium to your new point of equilibrium. Okay, remember in our IS curve, here was our initial point of equilibrium. How did we move to this new point? Well, with a decrease in interest rates, you had an increase in investment, which shifted aggregate expenditure. Once aggregate expenditure shifted, our level of aggregate expenditure was greater than the level of output, so we started producing more. How do we move from our initial point of equilibrium in our money market to our new point of equilibrium? That's what I would like you to plot and think about, and then I will draw it with you as well. Well, you can plot and think about it, and we'll take a break. In fact, should we take a break now, and then we can start with you plotting it? Okay, let's do that. Okay, cool. Take a break now. We'll start the next session with you plotting it. If you've got any questions, then you can come down and chat about it. For some reason, this computer today just doesn't want to work. Normal story.